Okay, I'm going to start now with lines. Lines is on paper 2 of your program, and there's quite a lot of nice topics in it. This is the visual from the website from maths.gcd.ie, and we just look at 2 lines with the point of intersection. The characteristic of a line is that it doesn't waver. It doesn't change up and down. It always goes in the same direction, forever. Never turns. It never has a turning point, just goes straight. If there are 2 lines, they may cross. The only time they won't cross is if they're parallel. These lines cross at this point here. Line segment. A line segment is defined by a bit of a line between 2 points, 2, 2 and 14, 7 in this case. I've just been asked to draw a line segment from 2, 2 to 14, 7. The way lines are drawn, lines are two-dimensional. And everything on your course is pretty much two-dimensional because all we have in the exam is paper. And because it's paper, there's only 2 dimensions on it. It's got an x-axis and a y-axis. Here is our x and here is our y. These are perpendicular to each other here. When you're reading, you read horizontally first, and then you read down the page. Now, in some cultures, we'd read from left to right. Other Arab cultures will read from right to left. But we all read horizontally first before we read down. So you always do x before you do y. So whenever you see a coordinate set x and y, x is always horizontal first. It's always this distance out. So the point 2, 2 is 2 and then 2, but 14, 7 is 14 out and 7 up, not the other way around. And that's our xy axis. We can also liken this very much to east and west. East and west on the x-axis, and then north and south. And we can live in this 2-dimensional space of this plane. The Cartesian coordinate, after Descartes, he thought about things having 2 parts, perpendicular to each other. Now, we're asked to find the midpoint of a line segment. And here's point 1, and here's another. 2, 2 and 14, 7. And instinctively, we sort of feel it's probably around here somewhere. Now, there's 2 parts to it. There's a 2 and a 14 for the x bit, 2 east and 14 east. What would be halfway between them? Well, if you started walking from 14 and somebody started walking from 2 towards each other, they'd meet at a certain point. They'd meet at point 8 if they were walking at the same speed. And similarly, 2 and 7, in terms of north, 2 and 7, if they started walking towards each other, they'd meet at 3.5. So you can get a good feel of this if you want to, just by eye or by common sense or by experience. But what we do is formally we draw it in terms of the 2 dimensions. And we say we dash this and we say, well, 2, 2, 14, 2 and 14, 7. So the difference between this point and this point is broken into 2 parts. It's broken into an east-west change of moving from 2 to 12, 2 to 14, which is a total of 12. And here, moving north from 2 to 7, a total of 5. And half of that would be half of 12, which would be 6. And half of that would be 2.5. So 2.5 would be halfway, and this would be 6. And if we went out halfway to 2 plus 6 would be 8. And if we went up halfway, we'd end up here at 8, 4.5. And we can see that on our midpoint here, that the midpoint of this segment is going to end up about there. Now, how do we get it mathematically? Well, we're interested in the precise numbers 2, 2 and 14, 7. Well, 2 and 14, taking the x side, well, this is 2 and this is 14. And what's halfway between 2 and 14? Well, you add up the 2 numbers, 2 and 14, and divide by 2. It gives you 8. If somebody is €2, another person's 14, you put the 2 together, you've got €16, you have 8 each if you're willing to share. So that's 8. Similarly, on the y side, or on the north side, we're looking at 2 to 7. 2 and 7 add them up, 9, divide by 2, 4.5. So we have our 8, 4.5. And that's our midpoint. And that's how we do it without any book. When we look at it from a book point of view, we say, let's use the tables. And we say the point 2, 2 is really x1, y1, 2, 2. The point 14, 7 is x2, y2. And this then is the point x2, y1, or 14, 2. What's this midpoint? Well, the formula says x1 plus x2 over 2, y1 plus y2 over 2. Get the two x's, 2 and 14, divide by 2. That gives us 8. Get the two y's, 2 and 7 divided by 2, 4.5. And this is the general formula. That's all it is. It's just adding up two numbers and dividing by 2. We turn now to the line segment and considering the slope. Slope is a very interesting part of your program because it links up a lot of concepts together, not just in the line. And the thing about Project Maths is they want you to get a sense of how everything is connected. The one really important significant change for you this year over last year's paper is that with Project Maths there's no choice in the paper. Everything is compulsory. Everything is interrelated. You can't leave out anything at all. So slope is an interesting point because it links up a lot of points for us. But let's look for the moment. Find the slope of the line segment joining 2, 2 and 14, 7. So here we go again, 2, 2 and 14, 7. And just imagine now we went for a walk. We're out here in 2, 2 on this east-west, north-south plane. And to get to 14, 2, we have to go east. Or we have to go in the x direction. And then we turn, we've only got, it's like Manhattan. They're entirely like squares, New York. You can't just walk through the buildings. Everything is a block. Everything is a coordinate. You have to walk around the blocks. So you have to go on the avenues, on the streets and whatever. So you go down here 14 and then you go up. Well, the up here is north and we're looking at 5. And that's in the y direction. So effectively what's happening is that if somebody says, I'm at A, how do I get to B's house? I get to B's house by saying, if you're at A, well, that's fine. Go 12 east and go 5 north. Or if this was on a horizontal, you might say 12 across on the horizontal, 5 high on the vertical. And that's how we define that. Now, the slope tells us how severe that lift is. How much high do you go for how much across? And we just put one over the other and we say 5 high for every 12 across. We write it as a fraction. So 5/12 is the slope. And that's an important thing that we pick up on the slope. So the slope here is given by how far up do you go, 5, for how far across do you go. 5 over 12. That's the slope. In your line, we call that m, the slope of the line. If we look at it, how do we get it? We get 14, 2, 14, 7, a total of 7 minus 2 is 5, 5 steps there. And 2, 2 to 14, 2, a total of 12 steps here. But while I was at it, I decided to put in an angle here, theta. Not that it has anything to do with the line, really. But it's exactly the same concept. Here's a right angle triangle, because we've defined everything in the line as x and y. And x and y are perpendicular coordinates. That's the Descartes system, the Cartesian system. So if these are all square, everything is perpendicular. So that's perpendicular to that. And if you look at this from a triangle point of view, that's an angle there. And anytime you ever get an angle in a right angle triangle, the first thing you do is you draw an arrow over here and you say that's the line that's opposite it. So this becomes opposite. You then say, well, this is the 90 degree, the biggest angle, and if the 90 degree is there, the one opposite it is going to be called the hypotenuse. And if the opposite and the hypotenuse are gone, well, you're left with the adjacent, really. So for this angle, if somebody said, what is the opposite over the adjacent? What is 5 over 12? Well, 5 is the opposite, and 12 is the adjacent. And 5 over 12 is slope. But 5 over 12 is also opposite over adjacent. And what's opposite over adjacent? Well, you can look that up, but that is tan of theta. So tan of theta is the slope, is m. Now, if we lose the formula for that, We say, how would we do this in general if we needed to look at the tables? Well, we'd say x1, y1 is the first point, x2, y2 is the second point. The formula says y2 minus y1 over x2 minus x1. Well, what's y2 minus y1? Well, this point from memory was 14, 7. And this point here was 2, 2. This point here being the difference. This is the 14 across and the 2. But the difference in height now is the difference in the y's, the highs. This height, the second one, was a high of 7, and the first one was only 2. Reflecting that the only difference here was 5. On the x on the bottom, the differences in x's, I went from 2 east to 14 east. And 14 minus 2 is 12. And that's 5 over 12, and that's my slope. So I could do this simply by drawing it on the graph and saying the slope is that, or I could go to the formula pages. So that's the slope. We're now going to turn to the length. What's the length of the line? How far is it from house A to house B, if indeed you are allowed to walk across the field, or it's a flat land or whatever, and you don't have to walk across all the blocks as before? Well, we figured out that this distance here is 12, and this distance here is 5. How do we get that length? You might want to write that down for me. What's that length? Okay, so we do that question. Looking at it, it's a right-angled triangle. So if you ever see right-angled triangles, think Pythagoras is in there in the mix. Pythagoras says that the square of the two sides here is equal to the sum of those is equal to the other one. So if this is A and this is B and this is C, A squared plus B squared is C squared. If we take the modulus of their lengths. Or if this was X, Y, or Z, or whatever you wish to call it. We might call that X because we might like it on the X-axis. We might call this one Y. We might call this one Z because it's not quite on either of the two axes. So what would that mean? It would mean that basically that the hypotenuse Z squared is equal to 12 squared plus 5 squared. 12 squared is 144, 5 is 25, giving a total of 169, that being Z squared. How do we get rid of a Z squared? We'd like Z on its own because that's not, these might be in meters, but Z squared would be in square meters. And square meters doesn't represent a distance. So we square that, square root that, square root that. Z is equal to 13. We don't bother with the plus or minus here because we're actually thinking about distances. So we only just take the plus of it. And that length becomes 13. And that's how we would do that. We take Pythagoras there, 12 and 5, 12 squared, 5 squared, 13 squared. So that gives us the length. Now, if we didn't have the numbers and we wanted to do it by general points, we'd say here's x1, y1, here's x2, y2, and the one in the middle, x2, y1. What's the difference between here and here? Well, let's look at this distance. This is all based on the x values. This is really x2, which is 14, minus x1. This distance here is y2 minus y1. And this distance here is a bit of a mess. But we know that this squared plus this squared is going to give us this length squared. That's great. So we know that this squared plus this squared gives us this length squared here. So therefore, this Z squared, writing it out fully, is x2 minus x1 squared plus y2 minus y1 squared. But we don't want Z squared, we just want the length. And how do we get just z? The square root, the square root. So this formula here is no magic. It's what we would have done anyway. It's 12 squared plus 5 squared all square rooted. And that's the general formula for it. So you'll know which one to look up, because you'll know if it's the midpoint one, or the length one, or the slope one you're looking at. Now, they might ask you in the exam, as part of your leading up to a question, to plot points on the xy plane. The xy plane is both positive and negative. You can basically go east or west, and you can go north or south. Or we will call that plus here and minus on the x-axis, and plus and minus on the y-axis, going that way, and the x going the other way. So the points there are 3, 2, means 3 out and 2 up, always horizontal first, minus 3, minus 1, minus 6, 1, and then 6, minus 2. So always horizontal first. Now we'll do these questions without any reference to a visual. We're just doing exactly the same questions, we're just doing the midpoints using numbers. And we can do this by using the formulae, or just calling them out really. But find the midpoint of the line segment between minus 3, minus 1, and 5, 3. So minus 3, minus 1, and 5, 3. You can consider minus west and 5 east. What's halfway between 5 east and 3 west? Well, minus 3 plus 5 divided by 2. Minus 3 plus 5 is 2. Divided by 2 is 1. So the point 1, east, would be 4 steps away from 5 east and 4 steps away from 3 west. Here we look at minus, the next one then is, how do we get the point minus 3 minus 1, 5, 3. There's loads of ways of doing it. You could add them up if you wanted. 5 and 3 is 2. 3 and minus 1 is 2. And then divide by 2 because it's the average of those, 1, 1. Or you can do the formula, x1 plus x2. You say, okay, let's go into shutdown mode. And you say, I have a formula for this. x1, y1 is equal to what? x1, y1 is minus 3 minus 1. x2, y2 is 5, 3. And you draw the table like that and you say, that's the box. The next part of your lockdown is to say, right, what's the midpoint? The formula is given as x1 plus x2 over 2, y1 plus y2 over 2. You say, oh, now I've done this, now I've done that. What's the next step? Oh, yeah. Plug the numbers in. Okay, that's fine. So slowly, x1 is here, that's minus 3. x2 is 5, that's plus, over 2. Comma, y1 is here, that's the minus 1. y2 is, that's the 3. Divided by 2, that's fine. Oh, now it's just, okay, minus 3 plus 5, that's 2 over 2. Minus 1 plus 3, that's 2 over 2. Let's simplify those, that's 1, 1. So there's so many different ways of doing that, but you've got the midpoint and it's done. Find the length, or modulus. Here we have the point 1, 1 and 5, 4. How far are they away? Again, you could draw this, but they're not asking for it to be drawn. Your syllabus specifically states that you're meant to be able to do this visually, graphically, algebraically, mentally, any way you want. Any solution is perfect. It's all in the section defined on the syllabus specification on the website of the State Exams Commission. So what they're saying is, how far is 1, 1's house from 5, 4's house? Well, the difference between 1 and 5, that's 4, and the difference between 1 and 4, that's 3. Looks like 4 and 3. 4 squared plus 3 squared is 5 squared. Looks like your standard Pythagoras one. But let's see. x1 is 1. x2 is 2. The formula for the line segment is this. So x2 is 5. So that's a 5. Minus the 1, that's 1. That's on the x side. So we're gone from 1 east to 5 east. So that's a total of 4. And then in the north, we've got 1 and 4. That's 4 minus 1 squared. Okay, you've got to square these because of Pythagoras. So that's 4 squared plus 3 squared. And that gives us 25 or 25 squared. But these are squared values then. If I square them, I've got squared meters. Oh yeah, I must take the square root at the end to get back. That's why the formula is there. 5. 5 is right. So that's the formula. It's exactly the same. Just as we did with the z squared, we had to take the square root of it to get back. Now we look at the slope. Find the slope. Find the slope of a line given 2 points on the line. And here we take the points 2, 3, and 4, 6. So again, it's useful sometimes to visualize this, but maybe they don't want it visually. They say they want it algebraically. I'm going from 2 east and this north to 4 east and that north. So as I move east, I'm going 2 additional steps, 4 minus 2. And north, I'm going 6 minus 3. I'm going 3. So I'm going up 3 for every 2 that I go out. That's quite a steep slope. For every 2 steps I go 3 vertically. It's quite steep. The slope is always this over that, the y over. It's the always on the angle side, it's the opposite over the adjacent, it's 3 over 2. Or it's here, y2 minus y1, x2 minus x2, the change in y's over the change in x's. And the m value turns out to be 1.5. So the m is 1.5, the slope is 1.5, etc. Find the slope of the line that joins the points 3, 3, and 6, 1. A bit different this time. Here we're moving from 3 east and 3 north to 6 east, but only 1 north. We're actually coming down. The slope is coming down. We'll show this visually in a minute. But we're actually going not up anymore. As I go east, I'm going south because I've gone from 3 north to 1 north. So the line is sloping downwards. So again, I use exactly the same formula. Here it is here. But the slope says I used to be here on the x. It used to go from 3 to 6, 1. The first point says y2 minus y1. Here I got 1 minus 3 and 6 minus 3. Oh, I have a minus on the top now. That's a minus. So the more east I go, the less north I go, the more south I go, I'm going down. That slope is negative. So for the first time, we're getting the idea the slopes aren't just positive. So let's just look at that for a moment. Here is the example of the first one. Should I have it here? And we have a line here with a positive slope. As I move east, I'm moving north. That's considered positive. So at 2 naught here, up to 2, 2. As I move in that small journey there, I go 1, 2, 3, 4 paces here, and 2 paces there. So that's a positive slope. Now, if I took a different line, and let's say I did something like this, a slope over here that was negative, and this point here is 9, 1, 2, 3, 4, 5. Minus 9, 5. And this point here is minus 2, 1. Here, if I were to put a marble here, it would roll forward. Whereas here, if I put a marble on this slope, it would roll back. This one would roll forward. So what's that slope then? Well, I look at it here, and I say, well, what's the change in both the x and in the y? Well, as I move across on the x, I'm moving from minus 9 to minus 2. That's a total of 7. And that's positive because I'm going east. But here I'm going south from 5 to 1. That's minus 4. That's minus 4 over 7. So the slope of this angle here, the tan of that angle, is minus 4 over 7. So that's a bit about slopes. It's a bit about midpoints. It's a bit about lengths. We're now going to start using the line. And we're going to look at examples where the lines do something, where they intersect with something, where they meet another function, another line, or whatever. So let's start with that. Example 1, line L1 we'll call it. We're talking about this line. We're going to give it a function equation. Y is 1 plus 0.5x. And we're going to draw the line. Interesting points about this line occur in not too many places, really. Because lines don't do a lot. They don't turn, but they're sort of just constant, I suppose. But this one here crosses the axis here. It crosses the x-axis here, and it crosses the y-axis. This is the y, and this is the x. So there are at least two interesting points, or more interesting than other points here about this line. So how do we find those? How would we solve that equation, etc.? So the question comes then, find the equation of the line given the points -6, -2, and 2, 2. We're going to use this line for a number of things. We're going to find its equation if we can. We're going to find out where it crosses things, etc. And we'll do as much as we can. We'll find the slope and anything we can with it. So it says, find the equation of the line given the points -6, 2, and 2, 2. So what we start with here is we could draw this by saying -6, -2, and 2, 2. This point here, A, and this point here, B. We're given 2 points on a line. If you're given 2 things, you can draw a line. 2 points, a point and a slope and an intercept, you can draw the line. You need 2 things. You can't do it with just one. So the formula for the equation in the book is y minus y1 is m into x minus x1. So let's use that for the moment. It says here that the y and the x are standard. The y1 and the x1 is just any point. So I'm going to pick the point -6, -2 as one of the points. But to do this, it says that in order for me to draw the equation of the line, I need first to know m. So y minus y1 is m into x minus x1. I don't know m. Oh, m is the slope. Oh yeah, there's a formula for that. Let's look that up. And there's the slope. And the slope says, what's the difference here in the values? And if we work that value out, we find 0.5. Let's see if you could have got that from the numbers. Going from east here, I went from -6 to 2. That's 6 west to 2 east, that's 8. In the time I went from -2 to 2, which is from 2 south to 2 north, which is 4. So 4 in 8, I went up 4 for every 8 I went across. 4 over 8, 1 over 2, 0.5. The slope is positive. So m is 0.5. I use that then to actually find out the equation of that line. So there's my m is 0.5. And with the equation of the line, y minus y1 is m into x minus x1. I say I can pick a point. And the other point on the line, I think, was called, we called it 2, 2 there. So y minus 2 is equal to m into x minus 2. So I could have found the slope here by looking at the 2 points, drawing the dashes, saying that's a step of 8 and that's a step of 4. I could have then used the formula here to get the slope, and I now know that it's 0.5 m. Okay. So where are we? We now have the equation. But m we know, so it's y, m is 0.5. So y plus, if we do all that, let's do that equation now here. We're given the equation from the book that y minus y1 is m into x minus x1. And the point we're looking at is the point, any point will do, but let's take this point here, 2, 2. So y minus 2 is 0.5 x minus 2. So why don't you solve that equation for me? Just do that. Do the rest of those calculations on that. Okay, let's go with that. We have y minus 2 is 0.5 x minus 2. Not really gone on the 0.5 there. I'm going to multiply both sides by 2. 2 times y minus 2 is equal to x minus 2. 2y minus 4 is x minus 4. 2y, taking the 4 across, is x minus 2 plus 4, which is x plus 2. 2y is x plus 2. But I really like it when the thing on the left-hand side is just a number on its own, or a variable on its own. I don't like the 2-bit. So I divide it now by 2. And I'm going to get y is equal to x plus 2 over 2. Or maybe y is equal to 0.5x plus 1. Or maybe y is equal to 1 plus 0.5x. It doesn't really matter which way I do that. So I've got the equation. Now, I just chose, when I was doing y minus y1, x minus x1 here, to use the point 2, 2. Because it was just one of the 2 points that I knew were on the line. But in the previous page, we used the point minus 6 minus 2. We could have used that point instead, and we turn out with exactly the same equation. So it doesn't matter which one you use. Okay? So we now know the equation of the line, and we say it's this. Y is equal to 0.5x plus 1. The question now, though, is where does that line, or when does that line, intersect with the x-axis? We've got the equation of the line now. This is the x-axis. And where is that point? Visually, if we draw it, we know it's at minus 2. But if we don't have time to draw it and they want it solved algebraically, how do we find that point? How do we find point A? Well, is there anything happening at point A that isn't happening anywhere else? Well, yes. Point A is on the green line, but it's also on the x-axis. So it satisfies both equations. Now, what's another word or another equation for the x-axis? What's it called sometimes? It's sometimes called y equals 0. Why? Because if you look at it, look at all the points on it. 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, minus 1, 0, minus 2, 0. Sorry, the second number is pretty boring. It's always 0. So this is the y equals 0 line. You never go north or south. You're always stuck on the number line here, just east-west. That's all you can do. You can't shift. So that's the y equals 0 line. If that's the case, at point A, not only does this equation here hold, but so does the other one. Not only is this true, but y is equal to 0. Both of those are true. So in other words, y is equal to 0.5x plus 1, and also y is equal to 0. Solve the two of those equations. Because if that's the case, we can say y is equal to 0.5x plus 1 is 0. Solve that equation for x. Leave that with you. So this is how it's done. We now know that one of the givens is that the line is given by the formula, y is equal to 0.5x plus 1, but also y is 0. So this is all equal to naught now. 0.5x is equal to, plus 1 is naught. And then if we move the 1 to the other side, 0.5x is minus 1. So half of an x is equal to minus 1. How do we get rid of a half? Well, we could multiply by 2, or we could divide by a half, and divide by a half here. Either way, we get x equals minus 2. And if you look at x equals minus 2, well, let's see. Let's see if we can find the equation under all of this. If x is minus 2, and y is naught, well, the y is naught is telling us it's on the x-axis. The x equals minus 2 is saying y is equal to 1 plus 0.5 times minus 2. Half of minus 2 is minus 1. 1 minus 1 is naught. Y is naught. The point naught minus 2. Sorry, minus 2 naught. So we look at the x first. Minus 2 naught. The point minus 2 naught satisfies the line and the x-axis. Is that okay? Next topic, check if a point is on the line. You're given an equation of a line, and you're told, here's the line, y is equal to 0.5x plus 1. And you're asked, is the point minus 8, 3, minus 3 on the line or not? You've got to figure out if it is, and see if it's there or not. So what you have is, you have to remember that every single point, minus 8, minus 3, is always xy. And the question is, does that pattern there satisfy y is equal to 0.5x plus 1? So give that a try. Do the numbers minus 8, minus 3 satisfy that equation? Okay, let's give that a go. Remember the line we're working from. We're looking at this line here, line 1, L1. We're asking the question, is the point minus 8, minus 3 down here? Is that on the line? Well, it looks like it is. And visually, if you had drawn it, and if they had asked you in the question to see if it was, and you said yes, and that was the way it was phrased, that would be fine. But if they say you're not drawing it, and you've got to prove it algebraically, is it on the line? We've got to look at it a different way. Well, we do have the equation of the line, and the equation of the line was this. Y is equal to 0.5x plus 1. But our value we're checking is minus 8, minus 3. So all we do is we put that in our box, and we say, how do we manage this? And we say y, okay, what's y? Is minus 3 equal to 0.5, x is minus 8, plus 1. Minus 3 is equal to half of minus 8 multiplying in the brackets will be minus 4 plus 1. Minus 3 would be, adding these up, would be minus 4 and 1 would be minus 3. That's 4 west and 1 east or whatever. And that's correct. If that's correct, it means that's correct. It means that's correct. It means the point is actually on the line. Had we chosen another point out here, and let's say we'd chosen the point 5, 0, we would have found that it wasn't on the line. Go through the same calculations again, and we say y is equal to 0.5x plus 1. We're now checking the point 5, 0, where x is 5 and y is 0. Y would be 0 equals 0.5. The x would be 5 plus 1. 0 is equal to 2.5 plus 1. 2.5 plus 1 is 3.5. 0 is not equal to that. So in terms of a question mark, we'd say that's not true, not true, not true, not a point on the line. Is that okay? That's how we would do it. Before I just leave that line there, I just want to sort of make one other final observation. What we did was we worked out the slope, and you remember that for every 8 steps out we went 4 up. We also said that if we were to look at the tan of that angle, that would be the opposite over the adjacent here. And that would be 4 over the adjacent. But just for a moment, look at this. Y is equal to 0.5x plus 1. In another part of your course, you do calculus. And you get a graph like that. And from calculus, you're asked to do, if y is that, what's dy dx? And what do you do if dy dx is 2x? You say the dy dx is 2, isn't it? If y is 2x, dy dx is 2, isn't it? You just get rid of the x bit, isn't that right? So what's dy dx at this equation here? It's 0.5. What happens when you differentiate a 1? You ignore it, don't you? So dy dx is 0.5. Interesting that the dy dx is 0.5, the slope is 0.5, and the tan theta is 0.5. Well, it's not actually that surprising, because they're actually all the same thing. The slope is dy dx, is m, is tan theta. So we move on now, and we look to line number 2. Line number 2, and we're saying this is a line with negative slope. Intentionally, we're looking down here. We say, how do we do this? Okay. We've got 2 points, maybe, and we say we've got a point here, minus 2, 4, and minus 4, 2. So it's rapidly falling. And we have the equation of the line given to us again. Now we have the intersection with our x-axis as before, and our y-axis as before. Here's our y-axis, that should be y, intersection with our y-axis, and our intersection with our x-axis. What I want to do is I want to find the equation through the 2 points with the slope of minus 1. So it's telling us here that we know we're going through the point 4 minus 2. That's a point on the line, just 1 point. And they tell us the slope. Now, a slope of minus 1 means that for every step you go east, you go 1 south. Here you're going 1 out, 1 down, 1 out, 1 down, 1 out, 1 down. So it's like a steps of stairs going down. Quite a negative, quite severe on the steps there. It's 1 for 1. The slope is for every 1 cross, you go 1 down. What's 1 over 1 when you divide it? It's 1. And 1 over 1 is the slope. What angle has a tan of 1? Actually 45, because it's halfway between horizontal and vertical. It's going down halfway. Not vertical and not horizontal. It's halfway, 45 degrees. It's quite a severe slope. You'd be walking down into a basement or walking down the stairs that's quite steep at that. Sometimes you get very shallow rises. You go into, say, a supermarket, or you go into a big shopping centre, and they have these escalators that take trolleys. And the slope is tiny. It might be 1 in 10 or something. It's got a very, very long run for quite a modest height change. Because they can't have the trolley on you like that in case it falls back. But equally, if you're putting a ladder against a wall, you don't have a ladder at a very low angle because it might actually just fall. But you put the ladder very often at quite a height. So you might envisage a ladder being steps like that. And the person here trying to climb the ladder to the wall. Quite steep. So that would be quite a high slope, positive. Ultimately, if you put the ladder vertically, it is a slope of infinity. But that's a slope of 45, slope of 90, 0. And similarly, on the way down, you're going down now. That's a slope of -1. Escalators in shopping centres might have a slope like that. Tiny amount, 1 in 20 or 1 in 30 or something. So nobody gets hurt. So the formula says, given a point and a slope, you look up the formula. You point and a slope. The point is 4 minus 2. The slope is m is equal to -1. And you look up and you say, where's the equation for that in the formula book? The formula says y minus y1 is m into x minus x1. Do we know an x1 and a y1? All we need for that is 1 point. So we do. So we have the point x1, y1. Do we know m? We do. We just plug in numbers then. So we say y minus -2 is this, and we get y is equal to minus x plus 2. Having done all the calculations through. Let's just look at that for a moment. What this is saying is that line 2, for some reason, has the equation y is equal to minus x plus 2. If you got that question in a totally different part of your course, and it was in calculus, what would you say dy dx of that would be? What's dy dx of minus x? What's dy dx of, if y is equal to 2x, what's dy dx? 2. If y is equal to 3x, dy dx is 3, isn't it? If it's x squared and all that, you do all fancy stuff. But if it's just x, you just take the number, isn't it? So what happens if it's minus x? That's really minus 1x, isn't it? What's dy dx? dy dx is minus 1. And what's minus 1? dy dx? M is tan theta. It's saying that for every step I go out, I go down 1. It's 1 in 1, but it's 1 down in 1. So it's minus 1 in 1. So minus 1 over 1 is minus 1, which is dy dx, tan theta, the whole lot all linked together. Is that okay? You're given 2 points, and you're asked to draw the equation. Here you're told, not the slope, but you're told minus 2, 4, and 4 minus 2. Can you draw the line now? Again, you say, well, there must be something in the log tables for this. Let's look it up. And it says that m is equal to, and all the formula there, and you say m turns out to be minus 1. Does that make sense? Well, as I went from 2 east to 4 west, 2 west to 4 east, that's 6. I went from 4 to minus 2, a drop of 6. So as I went east for 6 paces, I went south for 6 paces. A drop of 1 for every step, m is minus 1. The formula for the equation of the line then is this one. We plug in the same numbers. We can either use the point 4 minus 2 or the point minus 2, 4. We'll end up with the same equation, y is equal to minus x plus 2. So we can get everything in the line with 2 things. 2 points, a point and a slope. We could say a point, we could get an intercept or anything like that as well. So, and we can draw those lines once we have it. If, for example, they say y is equal to minus x plus 2, how would we draw that line then? Well, what we do here is we just say, let's make up values. And we say, what happens when x is 0? Y would be minus 0 plus 2, that would be 2. When x is 1, y would be minus 1 plus 2, that would be 1. Points are always x, y. So this point here is 0, 2. This point here is 1, 1. That's saying 0, 2 is on the line. That's saying 1, 1 is on the line. Once you've got any 2 points, you can draw the line. Find the slope, exactly the same. You've got the equation. You can get 2 points if you wanted. But if I had the equation y is equal to minus x plus 2, how would I get the slope? Well, what's the slope? dy dx. And dy dx would be minus 1. Or I could say, get a value. When x is 0, what's y? When x is 2, what's y? Now I have 2 points. With 2 points, I can use my m equation. I get the same answer anyway. So I can solve it there using the points if I want it. Picking the point when x is 4, y is minus 2. When x is minus 2, that's 4. Get the points and get my minus 1. Or I can do it through differential calculus in one line. Now, not bad, we're nearly there. Only 47,000 slides to go. No. We're now going to look at the intersection of two lines. Okay? This is where it gets, at least I suppose it's a bit interesting. There's a bit more going on than just the one. You do this in another part of your course with simultaneous equations. So we're going to do that this time graphically. Intersection, sorry, I better get some water. Now, okay, what I'd like you to do is I'd like you to solve 2x minus 3y is 1, and 3x plus 2y is 8, algebraically, with algebra. No graphs, just do the simultaneous equations. Take a minute or two doing that, if you don't mind. You don't have those lovely sweets, do you? I only took the one, I think. Doesn't mind you mind? Grand. What? What's still on me? We'll edit this bit out of the video. This has nothing to do with the line, but it shows you just how integrated the course is. When we were doing the course, we looked at every single line specification. In fact, we'll post those as well. You'll see those on the site as exam notes. And what we're doing there is we'll have two versions of the exam notes, but the first note is fairly dry. It's actually the official syllabus. But unless you go with the official syllabus, you really haven't got... You can't, we're used to doing that. We take official syllabus and do it and prescribe it. So what the official syllabus will say, lines one perpendicular to the other or whatever. So we will have taken every single one of those lines or bullets and have done questions on it. We'll also put that in a bit more English as well, where we'll say where two lines intersect, and you say, oh, that's what that means, without the formal stuff. So there'll be a link between both the formal mathematical specification in syllabus, and they can be a little bit dry. I mean, I do a lot of work in syllabus development, and they're for a particular audience to satisfy the examiners and that. But it does come down to very straightforward English to say, Can you do intersectional lines? Can you do perpendicular lines? Can you do where a line crosses a circle? Can you do this? Can you do that? I'll be cutting this a little bit out, but I'm going to do this question now by algebra, because you're meant to be able to do it by algebra, by visual, by whatever. I'm not including this in the line section because it's not to do with algebra, but I'm using exactly the same equations, exactly the same answer. It is in the algebra section, but I didn't want to confuse the line section by putting in algebra or vice versa. What we're doing as well, and what Becca is helping me with, Becca's in final year in computer science degree, what Becca's doing as well is we're looking at all the various parts of the course, and we're doing this, we're hoping this will work for you now, well for us. When you're watching the videos, and let's say you're doing something that leans on something else, you're using, say, something like we're leaning on Pythagoras that we've done somewhere else. We won't always have time to go back and do Pythagoras a million times in the system, because that would crack you up. You want to have it done once. But if that's the bit that's causing you the problem, we'll show you the link to what it's based on. So here in algebra, we're saying you can do this by algebra, but we're not going to do the algebra in the line, because a line is for, I suppose, drawing lines and for graphics. How would you do this normally? I think what you do is you make the x's the same or the y's the same. Isn't that right? So making the x's the same, I think the common idea here is to get them all up to 6. So if we multiply this by 3 and this by 2, we'll get 3 times the first one will be 6x minus 9y is 3. Multiplying the second one by 2, we get 6x plus 4y is 16. This is not rocket science. This is 2 bananas, or 3 bananas and 2 oranges, or that. Multiply by 2 and you get the other. Now, taking one from the other, we get minus 13y is here minus 13, or y is equal to 13y is 13, y is equal to 1. If y is 1, 3x plus 2y is 3x plus 2. 3x plus 2 is 8. 3x must be 8 minus 2. 3x must be 6. 3x is 6, x must be 2. So the solution to this equation says x is 2 and y is 1. And let's see if that's right. 2 times 2 minus 3 times 1 is 4 minus 3 is 1. That's correct. 3 times 2 is 6, plus 2 times 1 is 2, is 8. That's correct. So what we're saying is that if you were doing this purely by algebra, you would find out that x is 2 and y is 1. So the point 2, 1 would be an important point for you. Okay? We just leave that there as noise. In the system, you'd find that in the algebra section, but you wouldn't find it in the line section. What I'm going to do is I'm going to solve this entirely now in the line section, graphically, with lines, and I'm going to end up at the point 2, 1. Okay? So this section is gone. Okay? But it'll be in the other part of the course. So I'll start again now. I'll be close enough on time. If I'm over, it'll be a minute or two, no more. If anybody's needs to know about 3:30. Intersection of 2 lines. Here we have drawn 2 lines. 2x minus 3y is 1, and 3x plus 2y is 8. We've got this line with a negative slope and a line with a positive slope. And they conveniently cross over at some point. If we weren't told anything about it and asked for the point of intersection by eye, we'd look across and we'd say, that looks like it's about 2, that looks like it's 1 up, and you'd say, roughly 2, 1. Somewhere approximately around 2, 1, you'd say. But then they say, no, we want it actually accurately, please. So we say, find the point of intersection with the following equations. 2x minus 3y is 1, and 3x plus 2y is 8. We've done it visually from the graph. Now we're going to draw the lines and see where they cross. So we've drawn the lines. And we've done this before by saying 2x minus 3y is 1. If we make x equal to 0, what's y? If we make x equal to 1, what's y? X equal to 2. Or if we make y equal to 0, 1 or 2, what's x? And we just get any points and just draw the 2 lines. And if we're careful enough, we'll find out that they cross. Let's do this now by picking 2 points. We'll say, want to draw 2 points for 2x minus 3y is 1. I say, when x is equal to minus 4. How did I get x equal to minus 4? I didn't. I made it up. I just picked a value for x. It doesn't matter what value I get. Once I pick it, the y will be decided for me, minus 4, minus 3. I could have chosen any value for x. Similarly, if I do when x is 8, I find out that when x is 8, 2x minus 3y is 1. 2 times 8 minus 3y is 1. 16 minus 3y is 1. Minus y is 1 minus 16, which is minus 15. Minus 3y is minus 15. 3y is 15. And y is 5. All done here. And I get the point 8, 5. And that's another point. Why did I pick x equal to 8? I just did. It was a point to pick. I have the line here, and it says 8, 5 turned out to be a point on it, there. Minus 4, 3 happened to be a point. But if you had chosen the point 3 for x, what's the value when x was 3? You would have got a value there. Or 5, you might have got a value there. You would have said that's 5, 3. Or here, you might have got a value here at, say, this point here, 2, 1. Or lots of other points along. And any 2 points would have done. So it doesn't matter. You've drawn the line. Now you decide you want to do the other line, the line that's negatively sloping. And you say, OK, well, here's line 2, L2. And you say, what happens when x is 0? In other words, when x is 0 here, what's the value of this blue line? It seems to be up there at 4. How would I do that? When x is 0, 3x plus 2y is 8. Plugging in the numbers, 3 times 0 is that. That just falls out. 2y is 8. Y is 4. 0, 4. We always do the 0 first, the x first. So it's x, I'm not moving at all. I'm not moving east or west, I'm stuck. 4, I always do the north first. So 4 is positive. So that's 0, 4. That's the point. That's on the blue line. If I chose another point, I just happen to say, I wonder what the value is when x is 4. Again, it really doesn't matter what I pick. Chose this point here, and I say, if I was to look now, where would the line be relative to this point? Is it down or up, or where is it? Well, when x is 4, I plug in the numbers, and the line says 3x plus 2y is 8. 3 times 4 plus 2y is 8. 3 times 4 is 12. 12 plus 2y is 8. I leave the 2y here, I take the 12 over. 8 becomes minus. 2y is minus 4. I don't like 2. I divide to get rid of it. Y is minus 2. I get the point 4 minus 2. 4 minus 2 is here. 2 points, I have the line. So any 2 points would have done. I could have chosen a point back here or whatever, any point. Or not, or a lot of people will pick when x is 0 and when y is 0. That's great as long as the line doesn't go through 0. But any point will do. You get 2 different ones and you're fine. And you say, where did they cross then? And what happens here is, you look at the point 2, 1 here. It looks like they cross at 2, 1. And do they cross at 2, 1? Well, 2 times 2 minus 3 times 1 is 1. 3 times 2 plus 2 times 1 is 8. Do they hold? 4 minus 3 is 1. That looks right to me. That means 1 is 1. This is 6 plus 2 is 8. That's 8 is 8. And that's 1 is 1. It satisfies both. It's on the equation. It solved it. So we've done it by drawing them visually and doing it accurately. We've done it by drawing the lines. We've solved it we can solve it algebraically elsewhere, and we get our graph like that. Very last topic of all on the line section are perpendicular lines, when one line is perpendicular to another. And here we say, what's the slope of the equation this at the point 2, 1? Well, that's a funny question, because the slope of a line is the same at every point, because it's not a curve. But they say at the point 2, 1 here, this is the point of intersection, what's the slope of the red line? And what's the slope of the blue line? And how are they getting along there? How are they being drawn? So the line is 2x minus 3y is 1. How do you get the slope of a line? There are a few methods. One is that you plug in a value for x and get a point for y, another value for x and get another point for y, and you end up with x1, y1 and x2, y2. With these 2 points, you can get m from the equation. So you can find the slope of the line. Another way of doing it is to say that's just a bit too hard. That's too much like hard work. I can see on the graph here that this point here, this is 0.53, is a perfectly good point, and so is 8.5. And to me, that looks like I'm going up. This is 3, that's 8.3. It looks like for every 3 I go out, from 5 to 8, I go up 2. And that would suggest that the slope, as I step up the ladder here, it's quite steep now. That's 2 over 3. Opposite 2 over 3. That's quite a high slope. It's positive. It's not quite 45 degrees. It's not 3 over 3, but it's up around 30 degrees and more. That's the slope of the red line. How's the other line doing? Well, again, I could pick a point here and say, that's not a bad point here. That 2, 1 isn't bad. And I can say, in this region here, it seems to go from 0.4 to 2, 1. That would be 1, 0, 1. So in that gap, it seems to fall sort of from 4 to 1. That would be 3. And from 0 to 2, that would be 2. So again, if you're looking at the slope, remembering that that's the angle, it's the vertical over the horizontal, it's 3 over 2. And that would be the slope of 1.5. But we're going south here. As I go east, this is falling. That slope is negative. That 3 is not just a distance 3, that's a minus 3. Because when I move here across, that's minus. So that actually is a minus there, which makes that a minus there. So if I call this M2, for want of a better term, for line 2, this would turn out to be minus 1.5. And if I call the other one M1, because it's L1, M1 is 2 over 3. So I've now got 2 different slopes. Now what's going on? Find the slope of the equation of the line perpendicular to this at the point this. Well, before I get into perpendicular for the moment, if somebody said that the red line here was 2x minus 3y was 1, couldn't I find the slope a much easier way? Let's put all the y's on one side. How do I get rid of the x's here? How do you get rid of a plus on this side? If I don't like this plus x, I say 2x minus 3y is 1. And what gets rid of a plus? A minus. So I just take this and I say 2x minus 2x, 1 minus 2x. And they cancel. So the next line then becomes minus 3y is 1 minus 2x. Not really mad on the minuses and stuff, so I could multiply everything by minus, or if I wanted, I could take everything back. If I wanted, I could say minus 3y plus 3y is equal to 1 minus 2x plus 3y. And they'd cancel. So I'd be sort of okay. So I'd get 0 is equal to 1 minus 2x plus 3y. Or I could just flip that around here. I could say, most of you would say 3y is minus 1 plus 2x by just changing the sign. If I go a bit slower, I'll say 3y. I'll have to take the 3y here on this side, take the 2x over, take the 1 over, 2x minus 1 plus 2x there. Okay? Same thing. Or I could do it even slower than that. But in the end, I get 3y is 2x minus 1. But I'm not gone on the number 3. I'd prefer if that 3 wasn't there. How do you get rid of a multiplication? Just divide. So y is equal to 2 over 3x minus 1 over 3. That's the equation of the line. That's another way of writing the same equation as the 2x minus 3y is 1. It's exactly the same equation. I just moved things around. But if that's the equation, what's the slope? What's dy dx of this? What's dy dx of something like that? 2 over 3, isn't it? Because that just falls out. That's just a constant. So we have our slope there. Let's look at the other fella for a minute. What's the other slope? The other line. The other line was given as 3x plus 2y. And this is a bit easier, I think. 3x plus 2y is 8. If I don't like the 3x's now, I can move it to the other side. I can say 3x plus 2y is 8. And I can say minus 3x and minus 3x. So I get 2y is equal to minus 3x plus 8. I could divide by 2, and I could say divide by 2, and I get, well, how do you divide? You get rid of this. Minus 3x over 2 plus 8 over 2, which is y minus 3 over 2 is 1.5x plus 4. Now, somebody told you that was the equation. What's the slope? What's dy dx? Minus 1.5, isn't it? Is that okay? So now we know that these two lines have the slopes minus 1.5 and 2/3, either from all of these doing it by the triangles. We could have done it by the two methods with the m's if we wanted to. We could do it by the dy dx, and we have the two. Now, what does it say? It says the two lines are perpendicular if and only if m1 times m2 is minus 1. As it happens in this question, if I multiply 1.5 minus times 0.666, another word for 0.66 is 2/3, another one for this is minus 3 over 2. You see the way if I multiply those out, they might cancel? The 3 on the top, the 3 on the bottom, the 2 on the top, the 2 on the bottom. That turns out to be minus 1. As it turns out, we're asked to say, find the equation perpendicular through 2, 1. We go to 2, 1, and we know that the equation through 2, 1, what was the equation through 2, 1? We were told it's 2x minus 3y. 2x minus 3y is 1. From this equation, we found the m for line 1 was 2 over 3. By definition, the perpendicular one is m1, m2 has to be equal to minus 1. So 2 over 3 times m2 has to be minus 1. This is just equations now. We're going to figure out what m2 is. 2 over 3 times m2 is minus 1. How do we do that? I don't like the number 3. I'm going to multiply by 3. So I get 2m2 is minus 3. Don't like the number 2. m2 is equal to minus 3 over 2, which is minus 1.5. I have now found that if I have a line here, I can find the slope of that line, and by just a quick bit of maths, the slope of the line perpendicular to it. The slope of the line perpendicular to the 2 over 3 is the minus 1.5. If I wanted to draw the line through this point, I'd know the point, and I'd know the slope. There's a formula for that. And here we have it here, just drawn, the two together, the same two original equations, at point 2, 1. The original line, m1, is 2 over 3, because 3 steps up, 2 up, 3 across, 2 up, 2 over 3. And this one, for every 2 across, it's minus 3 down. So this is 2 over 3, this is minus 1.5, and these two lines are actually perpendicular. And you can see that here by just showing that that is a 90 degree. Each one of these is actually a right angle triangle, as it turned out in this particular case. And this is slide 50, and if you look at your notes, it's the same as slide 1, which says you've now reached the end of the lines. So thanks very much. Okay? Break now for half an hour.